Welcome back to Architecting Software, the SEI Way, Essential Steps Toward Mastery. Our next presentation is Architecture Evaluation, a Tool for Designing Systems that Meet Users' Needs by Felix Bachmann. This presentation will conclude with an open dialogue period during which you can ask questions. We will address as many questions as time allows. Felix Bachmann is a senior member of the technical staff at the Software Engineering Institute, working in the Architecture Tradeoff Analysis Initiative. There, he's the team lead for the Architecture-Centric Product Line Practices, a co-author of the Attribute-Driven Design Method, a contributor to an instructor for the ATAM Evaluator Training, a co-author of Documenting Architecture's Views and Beyond, and leading research on architecture design expert. And we'll turn the presentation over to Felix now. All yours, Felix.
Thank you, Trey. Hello, all out there. So I hope, with my, German accent here, that you will be able to understand everything that I'm saying. I will try to make it clear and as possible as I can. Well, first of all, what all of you, thank you. 70 countries, I heard. So for some of you folks, it must be past midnight. I don't know what you're doing there, but, thank you for participating here. Now, after we heard, from Rob, so kind of like the overview of architecture, in this talk, so the next hour, I actually want to focus on just plain one question. The question is, do you have the right architecture? That's the purpose of the next hour, to get to the point. Hopefully, after that, you have an understanding, when someone asks you that question, that you can answer actually that question. And you can answer the questions based on facts and not opinions. So that's the purpose. Before I start, here as what we usually do, ask you a question, just to see what you did so far. Okay?
So we got a quick polling question to help us gauge the audience here. And that question is, what is your opinion about architecture evaluation? A, it is very helpful. B, it's very helpful, but too much effort. C, it does not have a lot of benefits. Or D, never participated in an evaluation. We'll wait about 30 seconds for everyone to vote. Okay, I'm not able to launch the results, but we're getting a lot of D's, never participated. Looks like the majority. I don't want to hold us up too long, so we'll let you, we'll kick it back to Felix.
Okay, thank you. So, as Shane said, looks like a lot of D's, so never participated in evaluation. Well, that's actually very interesting to me, because how would you then ever answer that question? How would you ever know that you do have the right architecture? Is it just because it feels like it? Is it because, well, it's the same that you always did in the past? So, and that was good in the past, so why shouldn't the next one be good? Kind of like, all the topics that Rob mentioned, just an hour before. Now, I want to lead down a path to get to that answer in a more objective fashion, to come up away from opinion, to say, yes, I have a good architecture, or no, I don't. Let me start here first with our cycles here. Remember, you're not building a system just because it's so cool to build a system. You're building a system because you're living in an organization, and the organization wants to be successful with whatever the organization does. And the expectation is you build a system that helps the organization to be successful. That's the sole purpose. But also, what gets a little bit more difficult here, that this is not a one-time shot. It is a circle. Even in the ideal case, you build the perfect system that helps your organization to be successful. Just the fact that now your organization is successful will make that organization change. It hopefully will make it grow, which changes the requirements on the system again. Yep. And that cycle goes on and on and on. It is never ending. It is a cycle that everything changes and the system has to be adopted. But as you probably know, when you ever design systems, over time, it will get more and more difficult to actually keep up with the change, and the organization will get slower and slower and less successful. That is the big problem that we need to solve. And as Rob already explained, trying to build a system just plain from what the organization needs, in all the details, is difficult. There is a huge amount of information that need to be managed. We as human beings are typically not able to deal with that much information. We need some abstractions in between that helps us to manage all those changes with all the details that are necessary. And that abstraction is the architecture. So we put the architecture in the middle of that cycle, saying, okay, instead of having a one-step process, go from whatever your business needs into the system, we're saying, no, it's better to actually build an architecture and let the architecture drive the system development. So instead of having one big step, we have two smaller steps in there. So therefore, but also we have now two cycles. We have one on the left side, which means the purpose of that cycle is now to make sure that we design an architecture that will actually fulfill the business driver, the business goal, that makes your organization successful without building the system, without implementing a system. So drive that design. And I saw one of the questions that came up here, were the question, what is first? Are the requirements first, or is the architecture the first one? I think hopefully that cycle's answer. It is a cycle. So does a cycle have a start and an end? No, it doesn't. You start somewhere in that cycle. Maybe you start with the requirements and build an architecture. But while you are designing, you discover that, well, some of the requirements may not work that well, need to be adjusted. So you go in a cycle until you come to a point where you have an agreement and say, yes, that is a system that I want. But then, of course, we have the right cycle. After you design the architecture in a way that you are now fairly sure it will fulfill the needs that your organization has, you now also have to make sure that it is implemented in a correct way. And there's the other cycle. And again, it is a cycle. It is not a one-time shot. Here's the architecture, build the system. No. Here's an architecture, build the system, make sure it conforms to the architecture, and if not, go back and fix the system until the system conforms to the architecture. Only then you can make sure that the system will actually fulfill what your business wants. So that's the big picture. Now for this talk here, we are talking architecture evaluation. That means we are now focusing on the left side, on the left circle. Not on the right circle. I'm not saying with that, that the right circle is not important. For that talk here now, we are focusing on the left circle, and let's go there in a little bit more detail, what we are actually doing. The SEI has a bunch of methods that all support all the activities that you have in that circle on the left side. The one, as Rob already mentioned, you need to get the quality attribute requirements, which we have a workshop, quality attribute workshop, to do so. When you have those, you also need now to take those requirements and transform those requirements into an architecture design. There's a method for it, which is called the attribute-driven design method. And just doing a design is not good enough. You also need to write it down, because only what is written down can be followed and understood. And there's a tool for it, our views and beyond approach. And lastly, if you have the design, every activities, everything you do, you always need to validate and make sure that it actually fulfilled whatever you went out to achieve. And there's the Architecture Tradeoff Analysis Method. And that is where the architecture evaluation takes place. So for now, for the next minutes now, I will focus on that single point. Assuming you have some architecture and you want to know if that architecture is appropriate and does indeed support your organization to be successful. So let's recall. We started out with a question saying the question we want to answer is, do you have the right architecture? Let me specify that a little bit more in detail. More in detail means, will the design system solution that you have, will that solution have the properties that make your organization successful? Now, when you just pass that sentence, there are two things there that need to be understood to answer that question. The first one is, what does it mean for an organization to be successful? What I think might be successful for me might not be the case for you. So what is it that means to be successful? And the second thing to understand is the system properties. What are those system properties? If you remember what Rob said, you remember that he said, well, it's the function that the system has to provide. Because if the system does not provide the function that makes your organization successful, then your organization cannot be successful. But it is also if those functions will work in an appropriate way. How well do those functions perform? You can have all the functions in the system. If they are not providing their function well enough, then the system will be a failure. So what we need to find out is, what are those properties? And the assumption is, if you have an architecture that has the properties that makes the organization successful, then that is a good architecture. You see, I never said it is an architecture where I think, or you think, or someone else think it's a good architecture. The objective measure is, does this architecture that is proposed here have the properties to make the organization successful? If so, it's a good one. If not, it's a bad one. So now from the architecture evaluation, that brings us to that we need to have an understanding about three topics. You can only say if something is good or bad if you can actually measure it. That means it requires to have a yardstick. If you don't have the yardstick, you cannot say anything about an architecture. So we need to establish the yardstick, which is not that simple of a task. The second part is, architecture is a complicated thing. Even a simple system, all the information that you can have about that architecture of a simple system is typically so much that no one else can understand it in the whole. So to say, does the architecture have the right properties, requires a deeper understanding of the architecture. And then, if we have those two things, the yardstick and the understanding of the architecture, then we have to do the analysis. Saying, now look at the properties that I can see, are they now appropriate according to the yardstick when I put it on? Yes or no? To answer the question, I have a good architecture or I don't. So, let's focus on the first one. Let's establish the yardstick. The yardstick we need to make sure that we have a good understanding. Recall, we try to find an answer to the question, will the design system solution have the properties to make an organization successful? And with properties, we said, well, it's the functions by itself, but also all the properties that come with the function. And here the properties, I mean actually the quality attribute properties. Something like the timing, cost of change, security question like sensitive data, availability, you name it, and anything else. Those are the properties in the architecture that need to be measured. So any yardstick that helps us to do exactly that is a good yardstick. A yardstick that measures properties, quality attribute properties of the architecture. That's what we need. Now, here's the problem. Any function that you have in your system has a set of quality attribute properties. There is no function in the system that does not have any quality attribute properties. So now imagine you have a system with 1,000 functions. And every one of those functions may have, I don't know, maybe 10 quality attribute properties. Security, modifiability, performance, you name it. Then we are talking about 10,000 properties in the architecture. We are dealing with a big problem here. 10,000 properties. If you ask any architect, or if you are an architect, ask yourself, when you look at your system, do you know all those 10,000 properties and whatever, how many they are? Do you know them? Of course not. I do architecture since 30 or more years. I never knew all the quality attribute properties of my system that I designed. So only some of them. But even if I would know them, to answer, now look at the property and saying, is that property a good one or a bad one? Well, I don't know. So for example, I have a function that provides a result within half a second. Is that good? Or if a function crashes once a week, is that good? If only one credit card transaction per month is compromised, is that good? Well, we don't know. So where we need to go here is that we need to sift through all that information that is possible there. Now, we get a little bit of help. Fortunately, we do not have to know all those properties in the system. For many of those properties, generic statements like, as long as every request is served with an average time of 2 seconds, then that is a good system. That's good enough. So now we cut down from 10,000 maybe to 8,000 properties, just by that sentence. Or another one, which is it acceptable that if something goes, it is acceptable that something goes wrong as long as the user doesn't lose any data. Again, that cuts down a huge amount of information, which we don't have to understand. So back to our yardstick, having a yardstick that would help us to measure those unimportant quality attributes would be a waste of time. So don't even look at that. Don't even go there. But we also know there are a few functions in the system that come with important quality attribute properties. Those are the ones that we need to understand and focus our attention to. And a good yardstick will do exactly that. Will help us to have a way to measure those important quality attributes, properties of the system. So where does that yardstick come from? Well, remember our first cycle that we had saying the purpose of the system is to make an organization successful. Therefore, we need to know what it means for an organization to be successful. And it's the set of stakeholders that participate in that organization. They build the organization. They are the people who can actually say, what is it? What does it mean to be successful? So the yardstick has to come from the stakeholders. There is no other way. It has to come from there. Now, unfortunately, when you just go to the stakeholders and ask them, okay, what are your important quality attribute requirements that you can think of? Then you will get statements something like, we need to have a system that can be easily adapted to new market conditions. Or our system cannot have any defect in the field. Or we guarantee 24/7 availability. Well, those are, tough goals, but, designing an architecture to support that is almost impossible. Those statements are too much abstract to actually be helpful. But that's what you typically would get. So now you're at a dilemma. You need to talk to the stakeholders, because there is where the yardstick comes from. But what they tell you is not helpful to actually build the yardstick. So over time, we established a tool that we call the quality attribute scenarios. And the intention of that scenario is to exactly that, bridging the gap between what stakeholders articulate, when they talk what's important to them in terms of quality attributes, and the details we are required to understand when we do an architectural design. So we established quality attribute scenarios to bridge that gap between them, to take the input but make it precise and measurable so that it has some impact on understanding in terms of what it does mean for the architecture. So business goals can be translated into quality attribute scenarios such as, and I have two examples here. A customer requires a new auction algorithm. A developer implements and integrates that function within 1 day of effort. So here that scenario talks about a specific function, and it provides a number, something that I can measure. So I can sit down, and make a test saying, okay, now implement a new algorithm and measure how long it takes to do so. If I can do that within 1 day, then the scenario is fulfilled. If I can't, it's not. Another scenario would be an error occurs in a fielded system. Remember, we had that one business goal saying our system cannot have any fault in the field. But there is a chance that that happens. But then if that happens, the system should recover from that error without manual intervention within 5 seconds. So meaning even if there is an error, it needs to recover and no one sees it. So it looks like there was no error in there. That is, again, is something measurable, precise, that we can help. That is the yardstick that we need. Let me summarize. Building the yardstick means we need to focus on important quality attribute properties. The yardstick needs to be able to help us to do that. The next one is that what is important, those qualities that we need to measure, they come from what the organization tries to achieve, from the business goal. And we use quality attribute scenarios to translate those business goals into precise, measurable quality attribute properties. So that builds us the yardstick. Now I got a question here, so before I move on with the architecture, many of you asked what TSP stands for. In the circle that I showed, in the middle, there was an acronym shown that was called ACE, ACE, which means Architecture-Centric Engineering, /TSP. TSP means the Team Software Process. The Team Software Process is the process that we support here at the SEI to make development teams, and not only implementation, but also designing to support that process and make it happen. So I hope that answered that question. So now let's move on to the next one. We understand the yardstick. Now we need to understand the architecture. Yeah, I always started out, with saying the architecture is a complicated beast. There is so much to know about that architecture that no one on this earth can actually know everything about the architecture. And especially when you're not building the architecture, you may come to an organization as the evaluator. The organization asks you, tell me, is that architecture a good one or not? And your job would be trying to understand the whole architecture where a team of, I don't know, maybe 4, 10 people worked for a year or more or less, and trying to get all that information together. It's an almost impossible task for anyone to do. So, and looking at the architecture also means we need to see what the quality attribute properties are of that architecture, because that's the one that we need to measure. But, as I said at the beginning already, very seldom we know those properties or understand those properties. And if you look at documentation, well, there's almost never documented. Even if you think you have a wonderful documentation, you wrote everything down, I'm not sure that you can actually see those quality attribute properties. Let me give you an example. Here, that little diagram, you don't have to understand the details, but that little diagram is a piece of an architecture document. Very typical. If you would get an architecture documentation, actually would get a good architecture documentation, in quotes, the good, you would see something like the diagram that you see here. This is a little piece. So it is a decomposition of a second level component into the third level. So a little piece of it. And you see a structure here, you see some boxes, and you see some lines here. They even have labels, and it's a notation is chosen. That's UML, what you see here. Great. But can you answer those questions saying, what are the properties here? So can you say anything about performance looking at that? Well, I thought, I'm pretty good, when it comes to architecture, but when I look at that diagram, I cannot say anything about performance. Is that thing fast? Maybe, maybe not. I don't know. Is it modifiable? Well, maybe I can say a little bit. It looks like this one box with that lots of arrows going in and out. That is probably complicated to change. Maybe that might be not that modifiable. But that's all I can say. Maybe. I don't know. Security. I have no idea. Is that secure? Does it even have to deal with secure information? I don't know. So many of the things that would be essential to say, yes, I have a good architecture or not, are even in the best documentation are not there. Let me give you another example. It's a little bit better example. This is a sequence diagram, UML sequence diagram of a system. At the very minimum, at least, in that diagram, the people put some timing in there. So now I see numbers. That numbers now help me to reason about performance. Now all of a sudden I can say something about performance because I see times in here. So that is a little bit better information. It tells me about some of the quality attribute properties, where in that case performance. But nothing else. It still doesn't tell me anything about security or availability or you name it. Now, to get to an answer and saying, will the architecture have the properties, the right properties? We need to cut down the big problem to smaller pieces. We use something that we call architecture approaches. Architecture approaches means, first of all, you actually don't have to look at the whole architecture. Look at the important parts of the architecture. And what is important for the architecture is actually determined by the quality attribute scenarios that we take as the yardstick. If a set of stakeholders said, this is important for us, well then it's prudent to take that scenario and saying, okay, now what are the parts of the architecture that are involved in that scenario? And take them and look at those. If something is not involved in that scenario, ignore it. Again, it cuts down the problem into a small piece. So that's the first question to ask. What are the components of the architecture involved in that scenario? So you may get an answer something like this. This is the component that needs to be changed here. Which is good. We have a pointer. Now we can drill down and do some analysis saying, okay, how easy, how difficult is it to actually do a change here? But we also have to consider that when I make a change in some place, it might have a secondary effect on other places that might have to be touched too. Typically in a diagram, when you follow the lines, you get that kind of information. So I have primary and secondary effects from it. And of course, and so on. If I make a secondary change in the IT, that may require to have a change in other places again, and so on. So therefore, the second question to ask is, now, architect, what are the concepts that you put into place to make that change easy? And the architect may answer with something like, well, we localized everything that needed to change into one component. So you have one place in the whole architecture to actually deal with that change. Good concept. Or data structures. They have a generic interface around. So you can actually change the structures behind that interface without anyone seeing that change to the outside. Good concept. Those are architecture approaches. Now we cut down the problem from the whole architecture to some of the components, and from some of the components only to a few concepts which are put in place to make that happen. That means now the next question to ask is those concepts. What are the properties that those concepts have? So a property might be, now the architect, hopefully, in the ideal case, it is written down somewhere in the documentation. There could be a statement saying adding a new algorithm means specializing a generic class, like the auction manager, and a typical algorithm can be implemented within 4 hours. There it is. 4 hours. Here's the number. That's what we are looking for. To change a component, it takes some number. Now I have the properties. And there might be others in there, as you can read here on those slides. Those are the things that we need to uncover. When we have those numbers now, we can compare those numbers against what the scenario says. And just doing the math and saying, yep, okay, you'll be in the ballpark. When you come up with those numbers, we actually don't require that it's a precise number. A ballpark number is good enough. It tells us we might be able to achieve it. The details can always be done on the code level. So there's where we need to go. Side effects. Now we said, okay, we can see the architect actually thought about the problem, put some concepts in the architecture, and it has some properties which we can measure and saying, well, it might be good. But there is no free lunch. Every time you do something in the architecture to make something good happen, there will be negative side effects. There will be impact on it. And the architect needs to understand what the impact is. The negative impact. That's the next question to ask. So something like, putting something into one place that may actually create many dependencies to other components, which might be bad for security, might be bad for other types of changes. There might be an overhead a performance overhead that comes with it, those things. But that are the things that the architect has to be aware of. So for evaluation purposes, it would be great if the architecture documentation would be organized around those scenarios. Something like you have a scenario like failure during startup. Everything that talks to that and makes the case why that scenario is fulfilled. Have it organized together in one place so you can easily go and see and find the information. If you would have something like that, then an architecture evaluation would be very, I wouldn't say easy, but much simpler as it is of today. When you look at the SEI's approach, views and beyond, how to document architecture, you will find the concept of a view packet. A view packet means bits and pieces from views packaged together for a certain purpose. And here in our case, it's evaluation purpose. We have that together. So summarizing it up means to understand the architecture, we need to focus on the relevant components, the ones that are interesting. And they are determined by whatever the quality attribute scenarios say. We have to identify the architecture approaches that the architect put into the architecture to make them happen with their properties, the numbers. And we have to consider what the side impact is. Whatever you do to achieve something good, you have to pay with something. And is that what you have to pay? Is that acceptable to the organization, yes or no? So now we have our two things. We have our yardstick, and we have a fairly good understanding of the architecture, of the important parts of the architecture, not the whole architecture. We only know bits and pieces of it, but the important ones. And now we have to put them together to do the analysis. Now that we have those information, now we need to answer the question, the final question that we have is, do those quality attribute properties that we identified in those components, are they sufficient to support the quality attribute scenarios that we have? And if that is the case, is the negative impact that all those things have on all the other scenarios, important scenarios, is that acceptable to the organization? Yes or no? If I can answer both questions with yes, then I did my job. But be honest. It would be great that if all that information would be written down in the document. So that means that's all information that you typically don't see in those diagrams. If that's written down, if that would be the case, then just sitting down, reading the documentation would be sufficient to do an architecture evaluation. So if you out there ever did an architecture evaluation by just looking at the documentation, and the documentation did not include the information that I just showed, then you have to ask yourself, what did you actually evaluate? Then I would guess you probably evaluated against your own opinion. And that might be good, or it might be bad. You just don't know. Fact from our experience here at the SI is you do not get the documentation that would include all that information. Therefore, your only chance to actually be able to say something correct and factual about the architecture is to interview the architect. You have to talk to that person or to the team, whatever that might be. If the information is not written down, they are the only one who actually know what it is. So you have to do both. Talk to the architect, get the information. And it's the job of the architect to provide the evidence that those scenarios that are important to the stakeholders are fulfilled. No one else can do that. Only the architect can do it. And the architect has to provide the evidence to quality attribute experts. Need to convince those experts. So, for example, if it is very important to the organization that the architecture is secure, well, then the architect has to make the case that the architecture is secure in front of a security expert, the person that understands what security means. If the architect can convince that expert, the architect is secure, then you can say, yes, you achieved the goal. Your architecture will do what you put out to do. The other part is also, and that might be a little bit difficult for managers to understand. There is no architecture, there is no system that has no risk. Every system has. Because no one on that world had actually enough time and enough money to build the perfect system. There is always limited. You have a limited amount of time, you have a limited amount of money. Therefore, you can only build systems that are good enough. Not perfect. Good enough. That means whatever you do, there are risks. An organization needs to understand that there are risks. And that's actually a distinguishing factor between successful organization and unsuccessful organization. Successful organizations know the risks and they're able to deal with it. Unsuccessful organizations, they don't know the risk, they're always surprised. Something happens. Damn, how did that happen here? That's the difference between success and unsuccess. It never says, take the example of credit card companies, for example. Credit card companies are very concerned about securing those credit card transactions. That no one gets their hand on that. It depends an awful lot of money. But no one of them actually said, build a system where no transaction whatsoever can be compromised. No one is actually saying that. They say, okay, there is a certain level. And I don't know what the number really is. So let's just assume it would be if there is one transaction out of 1 million that get compromised. That's fine. We just pay for it. It's cheaper to do it that way than trying to get the perfect system. Those are definitions that your stakeholders need to make. And saying, hey guys, we could do that. It will cost you 10 millions more. Is it worth to you, to spend those 10 million? And they may say, no, it's not. So you can live with risk if you know what the risks are, because then you can set up yourself to deal with whatever the risk is. And the risks come from when the properties do not completely fulfill the quality attribute scenarios, or there is a side effect, a negative impact on other quality attribute scenarios. So let's summarize it up. To do the analysis means that the architect has to provide the evidence that the system actually possesses the quality attribute properties which will fulfill the quality attribute scenarios. And the mismatch between those properties and scenarios, that's the risk, and the risk that can impact the business goals. Just one slide here to our architecture evaluation method, ATAM. That's how we at the ACI do architecture evaluation. And as you can see here on that slide here, we have the two rows here. The top row is just concerned about the quality attribute scenarios. So the Yardstick, create the Yardstick. Those are the 3 steps here, from the business driver over the quality attribute to the scenarios. The second row is concerned about the architecture. Understand the architecture approaches, and the architecture decision in it. Then, after you have those two, then you do the analysis, and the analysis results in trade-off, sensitivities, non-risk, and risks. Risk meaning here there is a mismatch. The architecture decision do not support what the quality attribute scenarios say. And we, take those risks together. We do some analysis, looking in if there are common themes that happen there, and if so, then we say, okay, here your business driver that is in jeopardy because of those decisions in the Now, that was architecture evaluation on that part here. But here I don't want to stop here. I want to focus now the attention a little bit away from that evaluating the complete architecture to actually the design process. Because also, depending on what kind of system you have, you may have put a lot of effort in designing the right architecture. Then you go into an architecture evaluation, and the result of the evaluation is, sorry, you screwed up. That is too late. Many times, the organization don't have the time anymore to delay the delivery of a product, so they have to put something out and deal with the risk that they may get the wrong product. In many cases, it is too late to wait until the architecture is finished. Why not using all the techniques that I just mentioned for an architecture evaluation in the small during the design process? So in little steps, make sure, do bits piece by piece, make sure you do the right thing. So that you are sure when you're done and you will go into a big architecture evaluation, you actually have the right thing. And the result is, yeah, great job, good job. That's where we all want to be. So when it comes to architecture design, there's always a reason why you want to do something, either create a new system or change an existing system. So there is something that needs to be improved, something that's wrong. And it might be just because the business changed that you have. So a design can only be done if you have a goal. And the goal is what you need to achieve in the design. And the goal should be articulated in quality attribute scenarios because those are precise and measurable. Without quality attribute scenarios, I don't know how you will actually design an architecture when you don't have them. So get them. No matter if you have a greenfield development or a brownfield development. Greenfield meaning you start from scratch, new. Brownfield means you have an existing architecture, but you need to change it. If you have a greenfield, the best way to get the quality attribute scenarios is from the stakeholders. So why not having a short, little workshop, get the stakeholders together, ask them what's important to them, and make it short. And short, I mean a day or a day and a half. Because if you make it short, you force your stakeholders to talk about the important things, and not about all the other things they also may have, but are not important to them. Get the set of scenarios, get them prioritized. Then you know what to design against. If you are in a brownfield development, so you have an existing system, but it needs to improve in some way, then you typically can ask the question, what can I observe in that system that makes me unhappy? So there are certain properties in the system that obviously are not good enough. So what are they? What can I do with the system to observe that? If I can observe it, then I can specify again a quality attribute scenario that says, okay, now this property, make it so that in the future it has a different value. Again, we have a scenario for doing so. Now you know what to design. And as a rule of thumb, an architecture team of 4 can take care of one quality attribute scenario within about a week. Now, what the real numbers is for you, it just depends on how well established your architecture teams are. But as a rule of thumb, as a starting point, one scenario per week to provide enough evidence to make that happen. Now, take that evidence and now establish your peer reviews. And I'm pretty sure you already have your peer reviews there. But now in those peer reviews, go and be a little bit more formal. Take the techniques that we just talked about to an architecture evaluation. So meaning, take a scenario, pick one, ask the architect, what are the architectural approaches that you put into the architecture to make that happen? Show what the documentation is. Look at the documentation, if it's documented sufficiently. Ask for the risks that come with that documentation or with those approaches. List some to-do items and make a decision about if that reviewer is past the scenario or not. Very simple thing. You can do that for one scenario within 1 hour. If an architect cannot make the case within 1 hour that the scenario is fulfilled, then something's wrong. And if an architecture team can design the architecture for one scenario within 1 week, so having a peer review every 2 weeks for 2 hours is a very reasonable, low-cost thing to do. And what it leads to is, first of all, you will produce the right documentation. You will know what the action items are. You will know upfront what the risks are, which one need to be mitigated. You will know very quickly when you go back to the stakeholders to negotiate some of those requirements. Altogether, the key for achieving the goal. And that's it for this hour. Now I have a little bit time for question and answer.
Okay, before we get to our question and answer with Felix, I wanted to remind everybody that we'll push out a survey here near the end of Q&A, and we appreciate your feedback by filling that out. I also want to take a moment to point out Saturn 2012. And Saturn is our yearly conference, stands for Software Architecture Technology User Network. And it's truly that. The SEI has spent 20 years building a network of software engineers. So this conference brings together users of these techniques and real-world examples. Many outside speakers, not just SEI folks, talking about these methods and how they've brought value to their organization. So Saturn 2012 will take place in St. Petersburg, Florida, May 7th through 11th, 2012. And we'll send some follow-up information about the conference after the webinar here today. So let's get to some questions for Felix. First question from Mohammed asking, how can I assess the intangible benefits of architecture which makes sense to business staff?
How can you assess that? Well, just ask your stakeholders. If they want to know, when they have, they articulate, what is important to them. If they want to know if an architecture design that comes out, will actually fulfill what they need. I guess is, if you ask them, the answer will be, yes, of course I want to know that. So if that comes, then why not? And now it depends, how much effort you want to put in there. Do you want to do that in the small, or do you want to do that in the large? You can now either, in the small, sit down with that stakeholder and the architects and go through the formal process of an architecture evaluation. And here, really the important part is not stating any opinions, facts. That is the driver. Because stakeholders understand facts. And they may or may not like opinions. So stay away from them, but bring the facts. And show clearly, what can be done, what cannot be done. What's with the architecture there. If they see it the first time, they will love it. Every time when I did that with organizations, they were saying, wow, even just peer reviews, when they're just watching, what's going on, saying, that's the first time we actually got information out of it that was helpful. And if you get the stakeholder to that point where they can say that is helpful, then they want to see that over and over again. Then you have the foot in the door in making the architecture important.
Okay, next question for Felix from Christina asking, as customers aren't always familiar with quality attributes, how can we elicit these requirements?
Okay, that's a good question. And, I'm completely behind. Yes, it is true. The customer almost never know them. Well, they have sort of like a feel, but they never articulate them. And even if they would articulate, they never articulate them precisely. Now, there are two choices what you can do, and it depends on what your relationship to the customer is. Do you have an intimate relationship, so you only have a few customers to deal with? Yeah, or are you, let's say, in the consumer market? Yeah, so you have to deal with millions of customers. If you have an intimate relationship with a customer, then my strong advice is to get that customer in, have a workshop, a one-day workshop with them, where you actually, try to elicit quality attribute scenarios, and show them the tool, and have a facilitator who understands quality attribute scenarios. So our quality attribute workshop, to get the customer an understanding of what is required. And in most cases, it is not that they object against it. I don't want to say those detailed things. Yeah, it's not the case. Yeah, in most cases, they just don't know. They make assumptions, implicit assumptions, without thinking about the consequences. So if you get them in there for a day and can talk to them, and elicit them in terms of quality attribute scenarios, then you have something measurable, you can write it down, and can ask the question, if you would get a system that can do this set of quality attribute scenarios, would you be happy, yes or no? Yeah, and in all cases, the customers say, oh, that would be so great, to have that. Now, if you are more in the consumer market, so you don't have an intimate relationship with your customer, then in your organization, I'm pretty sure you have some placeholder for customers. People who understand what the customers actually try to say or articulate, and a placeholder for them. And do the same thing with them instead of the customer direct.
Okay, next question from Gaston asking, I understand that every function has quality attribute properties, but I find it difficult to see how functionality relates to QA scenarios. For example, what functionality do you refer in the scenarios you explained?
Right. If you look at this was one slide where I had two examples of quality attribute scenarios. If you look at those scenarios, both of those scenarios actually state a function. It's there. It's written down, and the function has certain quality attributes. So I had a modifiability scenario. So for modifiability, the function is actually that a certain component needs to be changed in a certain amount of effort that comes with it. But the scenario states that function. But also the scenario is just an example, a placeholder for a certain set of functions where it applies. To make it clear, when it really comes to architecture design, what you really have is actually a matrix. You could take, for example, let's take all your function requirements as rows and all your quality attribute requirements as columns in that matrix. And every time when you say, well, that quality attribute applies to that function, then at that point in that cell, you have a scenario, a quality attribute scenario that says, what are the quality attribute requirements, the properties, the number that actually applies to that scenario. Again now, as I stated before, if you would do that to the full extent, we are talking about 10,000 millions, depending on the system, of scenarios. Of course, you won't spend that time. You need to focus on the important ones. But that's where the connection is. A scenario always states a certain functionality, and states what the quality attribute properties are.
Okay, we've got a minute left with Felix, so we'll try to get a quick one here. Question from Abdul asking, what is the yardstick for deciding what are the important bits and pieces of an architecture? Often stakeholders do not know or are not technical enough to be able to help in determining this.
Yes, also a good question. And there, my advice is architects or the technical people are stakeholders too. It is the job of the architect to take care of the technical impact that it has, that certain decision have. Stakeholder may request, they want to have a certain function here with certain quality attributes, and they have no idea what it really means technically. That's why, when you remember my slide with those circles in there, that's why we have the left circle. The stakeholders tell the architects, I need that, and I need it tomorrow. And the architects sit down, they have to come up with a solution saying, I'm sorry, it cannot be done. And here's the reason why. Here's the technical reason why. And going back to the stakeholders and saying, well, if you really want to pay 10 million for it, we most certainly can do that for you. But if you don't want to, then we need to do something different. So don't forget, architects are stakeholders too. And that's it, I think.
Yep, folks, that's all the time for this session. There's tons of questions we couldn't get to, but I strongly encourage everybody to join the Saturn LinkedIn group or the SCI Webinar Series LinkedIn group. Post your questions there. A lot of our technical staff belong to these groups. See questions, start a discussion, and look for some answers there. Felix, thanks for a great presentation. We appreciate it.